Yes, class. Good evening. Am I audible to all of you?
Yes, ma'am.
So, who all are present right now? Abia, Fahad, Rifat, Sahal, Samia, and Zaid. Zaid, you have joined after a long time, no? I think last two classes or I think 2 to 3 classes you have missed. So, in the last class we had, yes, we were seeing some applications of magnetic field. Fine, sir. So now you will be regular, no? If you need the recorded lectures, no, just let me know. Just tell me the last lecture which you have attended, so I'll send you accordingly. Or just text me on WhatsApp, or even the group you can text me. Whatever is the last lecture that you had attended, then I'll send you the further lectures from your batch only. Now, applications of Biot-Savart's law, we had seen few things. Infinitely long wire, let's quickly revise it because in today's class we need everything. All those we need it. From here we had started in the last class. You have done till series combination of resistors. Okay, so identical cells portion, Kirchhoff's law you have done. Z. Start. Okay, I get it. Fine, I'll send you. And today you are attending, so this was fine. So magnetic field for infinitely long wire, it was mu naught I divided by 2 pi A. A was the position vector separation from the point of calculation and the current that you have. Then you have semi-infinite wire. Are you people preparing yourself for the test? Derivation, I asked you people from the first 3 lessons. 3 lessons are over by now. So at least 3 lessons should be done by all of you. Today I'm not taking the test. On Thursday, I'll take your test within the class duration itself after completing the portion the way I take it. So I'll be taking your test only the derivation portion. If anyone needs the notes of the just the derivation, let me know. The new students who were not there when we were discussing the first lesson and second lessons, because only one video I've sent because other many students are saying they need some more time. That's why. So let me know if you need any notes or what. Just text me. Then I'll send you some notes specifically for the derivations. Okay, Abhi, I'll share with you. I have the derivation notes for, I think, till chapter 3 I have it. Yes, I'll share it. So magnetic field due to infinitely long wire was this. If it is semi-infinite, it becomes mu naught I divided by 4 pi A. For semi-infinite, point should lie at one end. Fine. Then we had seen circular cases. For a circle, a complete circle, if a complete circle is there, that at the center of the circle, magnetic field is mu naught I divided by 2r. I am ignoring the number of turns. Number of turns are considered if n is the number of turns. Yes, Madhyal. Just the chapter 1, Madhya. I'll send you that also. I'll send you. So, yes, magnetic field at the center of a circular coil is mu naught I divided by 2r. If it's a semicircular coil, then it's mu naught I divided by 4r. Fine, till here we did. One more case is left. This we had completed. So, I'll write it here only. Magnetic field for a circular arc. Circular arc means a random arc is there. Not a complete semicircle. What is a semicircle? Semicircle is a circle with angle 180 degree, subtending angle 180 degree. If it's a random arc, subtending angle, let's say alpha. Alpha is the angle which has been subtended. So this becomes the radius and this is the length of it. And again, we will be considering DL length only. So likewise, the way we had started in the last class, consider a small element of DL of the wire. Then magnetic field due to the element, you will apply the Biot-Savart's law. Angle will be 90 degree. These things were for the explanation for the circular. Now till dl it will be the same. Mu naught I divided by 4 pi capital R square was the constant earlier also. In the last classes for circle, for semicircle, these were the constant. So some students were not there in the last class. No, see mu naught I divided by 4 pi dl R by R cube. This is just the vector form. If you put angle 90 degree, why? Because dl is the curved portion. So from the dl, that is always directed tangentially, and radius is along the center, directed towards the center. So angle is 90 degree. Till here the derivation for a circle, semicircle and semicircular arc, the circular arc remains the same. Difference arises by the length. Other students who were not present in the last class. See, as you change the value of dl, the values of other quantities will also get changed. See. Right now I have to take a different value of L. So can anyone tell me what is the value of DL that I should take this time? Last classes you people have told me. For a circle it has to be 2 pi r. For a semicircle it has to be pi r only. So for this DL, what should be L over here? Can anyone relate? Just to try. I'll help you. I'll help you with it. I'll tell you. Just to try.
Length of arc, right?
Yes, length of arc. Yes, sir.
There's a formula for it. I
Yes.
don't remember.
Yes, correct. You've got it. You've actually got what I wanted to ask. Length of arc this time. For a circle, we used to do what? DL, DL, DL. All the smalls DL got added together. And every DL gave you the length of the circle, which was 2 pi capital R. This time it's a then the previous case was semicircle. DL, 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 all integrated together will give you the circumference of a semicircle. That was pi R. Here it's length of the arc. So there's a relation between length of the arc, angle and radius, as rightly answered by Sahal, because DL added will give you the length of the arc only. So there's a formula for it. So length of arc is, I'll write down, length of arc is angle multiplied by the radius. Remember Sahal, I think now you must be able to recall it. So magnetic...
And something 180 was there, right? Wasn't there?
180 specifically. If you just put down the values of angle, then different values. Otherwise, the definition of angle is it's the length of the arc divided by radius. So from there we get this formula. All right.
Okay, ma'am.
So mu naught I divided by 4 pi r square is there. Integration of L. This will give you alpha into r. This here. So one radius gets cancelled, and this is the final formula that we have. So what's the formula for a circular arc? It's mu naught I alpha. Alpha is the angle subtended by the arc. I'll write down. Alpha is the angle subtended by the circular arc. So divided by 4 pi r. So please remember all the formula, because here we'll be using it. So if n is the number of turns, so this becomes mu naught I alpha divided by 4 pi r multiplied by this number of turns. This is for n as 1. So note down till here, note down this derivation. Okay, before you note it down, let's discuss this also. In the last class, I had not discussed this. We just discussed it in brief. I told you, you will discuss it in the next class once we complete it. Right hand thumb rule we have been using. We have been studying right hand thumb rule. Or if a point is located here, then how to do? Put your fingers in the direction of current, curl your fingers towards the point, thumb gives you the direction. This we have done. Another one we have done is curl your fingers along. Now see, this says what? The way the curvature of current goes, no, the sense of current is going. Keep your fingers like this. I'll tell you, this law is helpful in case of electromagnetic induction also. When you study EMI, there you will see this law is very helpful. That's why do not neglect this law, because circular coils will come often. So curl your fingers along the sense of current. See the first figure. It's moving like this. So I have to curl my fingers like this, Do you see? Like this. This is what? This is clockwise. See, this is clockwise. Are you able to see this? This is clockwise. So clockwise, thumb is leading where? Thumb is leading into the page. So it means for this current, direction of magnetic field is inwards. For the second one, see for the second one, current is flowing like this. So I have to curl my fingers like this. This is the motion of current right now, anti-clockwise. This will be anti-clockwise only. Obviously, I cannot curl my fingers further into a proper circle, but curling will lead me here. Thumb is pointing away from the page. It is pointing towards me. It is pointing away from the page. So that means magnetic field is what? It is outwards. Yeah, this was there. Now we'll be doing questions. So just revise the formula and have the formulas ready with you. If not, if you do not remember it, at least you can turn the pages and try the questions. First, copy this down. And please write all the statements again. I had the advantage of erasing it. You people have to write it. Yes, Z. Z, this part only or the direction? Direction, Z? See, direction is how. Anti-clockwise and clockwise, you know. Anti-clockwise and clockwise, you know. So first figure, Z, tell me one thing. In the first figure, is the current moving clockwise or anti-clockwise? First tell me this by looking at the first figure. It's clockwise. So see, if I keep my curl my fingers like this, you have to curl your fingers along the sense of current. Means how the current is flowing, how the current is moving. Likewise, you have to curl your fingers. So if I curl my fingers like this, are you able to see these are moving anti-clockwise? So it means the direction is wrong. Let me reverse it. See like this. Look at the camera. See like this. This is what? This the direction is clockwise. So where is the thumb pointing? If I'm curling it over here, so thumb is pointing into the page. So direction of magnetic field becomes what? Inwards. Similarly, Z, tell me for the second figure, is the current moving clockwise or anti-clockwise? Anti-clockwise. So now if I keep my fingers like this, see, this is the clockwise direction. If I, let me just reverse it, let me check it with this. And just remember, you have to use your right hand only. So if you curl your fingers like this is the anti-clockwise direction. So it means I have curled my fingers along the sense of current. So direction of thumb gives the magnetic field. Now clear to all of you? Zed, clear to you? All right. So note this portion down. Magnetic field at the center of a circular arc, and we will be practicing questions. All the question mixed up. Wire will also be there. Circular wires will also be there. Semicircles will also be there. You can take any angle, whichever angle you wish. Alpha is just the angle that has been subtended by the length of the arc. So the arc is subtending this angle alpha. So you can take it as theta as well, whatever variable you wish to take. It's just that it's the angle that has been subtended at the center. See this question. Now you have to calculate the magnetic field at the center O. So how to calculate it? Different questions will be given. So we'll be practicing many questions. See, different figures are there. First figure you can see infinitely long wire. Just divide it into segments. This is first figure. This is second is semicircular wire. And this one is what? This is another infinitely long wire. Remember in the last class on last Thursday when we were discussing the numericals on the infinitely long and semi-infinitely long wire, there we had seen that if the point lies on the axis of the wire, then the net magnetic field at that point is zero. Reason is that because the angle becomes 0 degree. If you put angle as 0 degree in the Biot-Savart's law, magnetic field will be 0 degree. Sine 0 is 0. So magnetic field will come out to be 0 degree only. So that's why at the axis, if you have the point located at the axial line, at the axis of the conductor, or the wire, if you have the point located, then at that particular point the magnetic field comes out to be 0. So if we talk about the net magnetic field over here in the exam, see how will you write? In the exam, first you have to mention magnetic field because of the first segment. So since the point is lying on this axis only, see this is the axis, magnetic field due to this segment will be 0. Then magnetic field due to the second segment. This is a semicircle. Current is I, radius is R. At the center of a semicircle, what's the magnetic field? In the last class, we had seen mu naught I divided by 4R. Fine. And last one, magnetic field third. This will also be 0 because this point is again lying on the axis of it. Now the net magnetic field. before we move on to the net magnetic field, you have to have the direction as well, because magnetic field is a vector quantity. You have to write the direction as well as you have to write the magnitude of it. Remember, in many of the tests that have been conducted of this lesson, no, students have a habit of just omitting the direction. They just write down the magnitude and get the correct answers. But your answer and your marks will be cut if you do not write the direction for a vector quantity. See, magnetic field's direction for the second one, it's a semicircle. Current is moving in which direction? This is the direction of current. It's moving clockwise. So curl your fingers clockwise. Thumb is going into the page. Inwards is which axis? We have done this in the last class only. Inwards is the negative z axis, that is minus k cap. So net magnetic field will be 0 plus minus mu naught I by 4 r k cap plus 0. So net magnetic field will be mu naught I divided by 4 r into minus k cap. This gives the direction this much Tesla. Minus z-axis, yes, negative z-axis, Samya, good. Note down this. I'll do one more question to all of you, then please do it. No, not the point Z. See, this point is I. This is I. This is current. Symbol of current is I. Point O is the magnetic field where you are calculating. This is the center. See, you have to calculate the net magnetic field because of all the segments at this point. This is not Z. This is I, current flowing. Did you people try this second one? Second question. Let's discuss this one. See, these are two circles given to you, two concentric circles are provided. Now the radius of the, let's say this is the first circle, this is the second circle. So first circle's radius of first circle is B. Radius of second circle is what? Radius of second circle is A. Current flowing in the first circle is 2I. Current flowing in the second circle is I. B1, magnetic field for the first circle. So the formula for magnetic field for a circle is mu naught I divided by 2R, right? Mu naught I divided by 2R. So can any one of you, Madhya, can you try this at the center O for this first circle? What should be the formula of magnetic field? Current you're able to observe. General formula is mu naught I divided by 2R. Yes, Madhya. Yes, Madhya, you're not audible. Mu naught I divided by 2R is the general formula for magnetic field for a circle. Just look at this and substitute it over here. Okay, mic issues. All right, Madhya. Yes, we were not able to hear you. Just type it. Mu naught will be the same. Then what else? What should I write after mu naught? Yes, Madhya. Mu naught I have written. Next.
Yes, it will be mu naught 2I.
2I divided by?
It will be 2B.
2B. Perfect. This is how we write it. Sahal, can you tell me the direction for this? Minus K cap plus J cap minus J cap plus I cap minus I cap, according to you, Sahal. Or inwards, outwards, whatever suits you. For this.
Plus K cap.
It will be plus K cap, means outwards you're saying, no? Positive Z axis. So
Yes,
you are
ma'am.
right. Anti-clockwise, and then thumb is pointing outwards. So definitely.
Yes, pointing towards me. So plus K cap, right?
That will be plus K cap. Perfect. Now, magnetic field for the second one. Fahad, please tell me the magnitude for this circle. Either unmute yourself or type me the answer. What is the magnitude of the magnetic field for this circular coil? Out of one. First one, Madhya and Sahal have answered. This is the second one, is the outer coil. At the center, current is there, radius is there. What should be the formula for it? Fahad.
Mu naught I by 2A.
Perfect. Mu naught I divided by 2A. Because current flowing here is I. Radius of this bigger one is small a. So that becomes 2A. Right. Abia, can you tell me the direction of this, which Fahad has answered right now? Abia. Abia, hurry up. See, Sami and Zaid have already answered. Outwards. How are you choosing outwards? First, tell me, Abia, is the direction of current clockwise or anti-clockwise? According to you, for the second circular coil, is it clockwise or anti-clockwise? Anti-clockwise. It's anti-clockwise. This one. See, the clock moves like this. Just imagine the movement of the hands of the clock. See, this is the circular coil, this outer one. Current is flowing like this. This is clockwise or anti-clockwise? clockwise. So curl your fingers clockwise. If you curl them like this is anti-clockwise. If you curl them like this is clockwise. Now do it. And now tell me, where is your thumb pointing? Into the page, out of the page? Just check it right now. Curl your fingers clockwise, because as you've rightly answered, current is flowing clockwise. Just curl your fingers clockwise and use your right hand. Do not use your left hand. If you will use your left hand, you will get the opposite answer. Abhi, did you get it? In the paper. Yes, yes. It can we write it just negative minus k cap? You can write like Zaid and Samia were answering minus k cap, so that's also correct. Got it, Abia? Why it will be minus k cap? Because it is into the paper, and this is which axis? Negative z axis. Fine. So good. Yes, this will be minus k cap. Now the net magnetic field, you have to write this way only, you have to answer in the exam. First magnetic field, second magnetic field, third magnetic field, then net magnetic field, along with their directions. Do not omit the directions. So net magnetic field will be what? Just add both of them. So this will be mu naught 2I divided by 2B k cap, and this becomes minus mu naught, or let's write plus only, plus mu naught I to A. Here let's write it as minus k cap. If you wish, you can further, to simplify it, you can take the commons which you are able to observe. Mu naught I k cap divided by 2. This much is common. From here, what is left? 2 is left. From here, anything left? Minus 1. From here, minus 1 is left. So 2 by B minus 1 by A. This is your answer. This much Tesla. Right? Just note this down. We'll do some more questions on this. See now in this question third, there are 2 coils. This is first coil, this is the second one. But see, orientation is different this time. First coil is kept in which plane? It is kept in x and y plane. X y planes mean what? If this is the x axis, this is the y axis. So this plane is the xy plane. This plane, y-axis and z-axis. Y-axis and the z-axis. This is the YZ plane. And this is what? This is the x-axis and the z-axis, xz plane. So xy plane, yz plane, xz plane. Can you tell me in which plane is the second coil kept? Any one of you? In which plane is the second coil kept? Which plane? Yes,
YZ?
YZ. Perfect. See, it will be YZ only. It's kept like this. It means YZ. So this is the plane, YZ plane. Okay, Fahad, I'll repeat. XY plane means plane within the x-axis and the y-axis. This is your x-axis, this is your y-axis. So this plane, this is known as xy plane. If anything is kept like this, within the x-axis and is kept in the y-axis, right? Then you have y-axis and the z-axis. This is the z-axis, this is the y-axis. If anything is kept in this way, like this, y-axis and the z-axis, this is known as the YZ plane. Clear? If x-axis is there and z-axis is there, this plane is known as xz plane, like this. This is what? This is x-axis, this is z-axis. Now is it clear, Fahad? Understood? The planes? Alright. So second one is kept like this. By looking at the figure, you can see the coil is kept like this. First one is like this, second coil is kept like this. This was just to make you understand which planes are there, because then only you will be able to get the directions. So let's talk about the first coil. First coil is this coil, which is having the radius A, current, this much amount of current is flowing. So again, let's start with Samia. Samia, can you tell me what should be the magnitude of this coil? Magnitude of magnetic field at the center. Yes, Samia?
Mu naught I1 upon 2A.
Yes, right. Mu naught I1 upon 2A. So magnetic field 1 becomes mu naught I1 divided by 2A. Rifat, can you tell me the direction for the first coil? See, this is the direction of current, direction of magnetic field for the first coil. Rifat, just try. It is going clockwise or anti-clockwise. At least identify this. Clockwise. So curl your fingers clockwise. See, is your thumb going inwards or outwards? Rifat. If you curl your fingers clockwise, is your thumb pointing into the page or out of the page? See, just curl your fingers clockwise. Inwards. It's clockwise. Yes, Madi, it's clockwise. It is going inwards, right? So inwards is which axis? Negative Z axis. Clear, Rifat? While it will be minus K cap. I hope it's clear to you. Good. So it will be minus K cap. Now magnetic field for the second coil. Z, can you try the second coil? What should be the magnitude of the second coil? mu naught I divided by 2b. I2. Right, current is I2. Yes, that's right. I2. So this will be what? This will be mu naught I2 divided by 2. Rufia, can you just try the direction of this? Okay, Zaid, I've read your direction. Others also respond in the chat box. What should be the direction for second coil? I want to know the direction of magnetic field for the second coil. Rufia, you also try. Sayyida Rufia. Just see the flow of current. So if the current is flowing, just curl your fingers the way current is flowing. See where is your thumb pointing. I want others to answer this part as well. Everyone to answer in the chat box. Okay, Samya. Fine, Fahad. Others also try. Madiha, Sahal, and all those. Rufia, you also try. Okay, Rifat. Any other answer
Ma'am, will it still be K cap or something else?
that you tell me, Sahal? Sahal has answered. I think you have
No, I
answered.
haven't.
You haven't. No,
No, I
Samya
haven't.
has. Try, Sahel. See, there's no boundary of K cap that every answer should have K cap. If you're getting another value, just let me know. Okay, Fahad. Fahad and Samya are near the answer. Not exactly correct. Madiha. No. Just try. Any other answer coming? Apart from what you people have answered, J cap, I cap, K cap. Sahal, do you want to try?
I'm not getting. I think it's minus J cap.
Minus J cap. All right. C class. Your coil is kept like this. Fine. Now your answer is right, Fahad. The only correct answer has been given by Fahad only. See, the coil is like this. Current is flowing like this. See, in the diagram, you're able to see current is flowing like this. Current is going into the page, then coming from the bottom, then going into the page, coming from the bottom. This is the motion. Yes, Samya. Now you people, I think, have got it. Fahad and Samya. Curl your fingers along the motion of current. Where is the thumb pointing? Negative I cap. Yes, sir. So this is now the curvature of current. It's not necessary every time that it will be this or this. The planes can be changed. Had the coil kept like this, it could have been J cap or it could have been minus J cap. Right now it is minus K cap. If the current was coming out, it would have been plus I cap. So minus I cap is clear to all of you. If anyone has not understood, ask me. So this will be minus I cap. Now the answers are pretty obvious. Net magnetic field will be what? It will be mu naught I1 minus K cap divided by 2A plus mu naught I2 divided by 2B minus I cap. One more question we'll do, but at least try that question by yourself because these kinds of questions are very, very common for your class 12 from magnetics. These are special questions of magnetics, very important questions. So note down this. We'll do one more question.
Ma'am, what's below 2R? Is it Z or I? Below 2R.
I. Current is I. This one, no? This one you're
Yeah.
saying. Which one?
Yeah, that's the one.
This is I. Radius is 2R. This small radius is small. This radius is R. This whole radius is 2R. Current I is flowing in through the entire wire. And angle subtended here is pi by 3. Now tell what should be the net magnetic field. If anyone is getting a long answer, like because we have to write no, the net magnetic field, you can submit your answer on the WhatsApp also. I'll check the solution. But at least try this one. Then we'll move to one
Ma'am,
derivation.
what is 1 here, figure 1 and figure 2 here? What is figure 1?
See, division, no, how we divide it. You're asking this.
Yeah, like 2 figures are there, right? You have to
Not
find.
two figures are there. Not two
I
figures
mean,
are there. This is the first arc. Fine.
okay.
This is the second in a long wire. This is the third one segment. This is the fourth one. Fine. Now try
Okay.
all. No, not wherever the current. See, you have to identify the segments. Fahad and others also. Tell me, is this a shape you have studied ever? This is not a shape. You haven't even studied this. You have to identify shapes which you have studied. See, net magnetic field for this whole figure will be something which you do not remember, which you will get at the end. So what you have to do, you have to divide it into segments which you are aware of. So right now, like I was able to identify, this was a this was a circular arc. So we have done this one figure. Wire we have done on the axis, this O point is lying. Another arc, radius is different, angle is same, current is same. So some value will be there. Again, this point exactly at the end. So I am able to identify this. I am able to identify this, but I am able to identify this. I am not able to identify this. So I'll divide it into segments which I prefer. That's why these questions are important. Get it? Got it? Because otherwise, very easy. You just have to put it into the formula. You have to divide it into figures if the random shapes are given. You know, in some questions are there. I think in your assignment I have given. I don't remember. Some questions are there. A circle is kept like this, and from here a semicircle, an arc has been cut. I have not drawn it perfectly like this. This is that. So how to solve this? This figure you do not know. What you can do for a circle, you can do subtract 1/4 of it. This was 1/4. I have drawn it. Let me just show you how to solve all these figures if you get. This was a kind of question you got. So for a circle, subtract 1/4 of it. You get it? And then for this quarter, the angle subtended is 90 degree. So likewise, you have to check out the net figure. For angle, we can use 60 degree. Like for in this case, no, 180 divided by 3. Yes, definitely. You can use 60 degree or you can use pi by 3 also, because pi will get cancelled. You can directly write alpha as pi, because in the denominator you will have 1 pi as well. And I think it's better if all of you submit your answers on the WhatsApp only, because I think you'll get a long question. So you can submit it on the WhatsApp. I'll just check, not like a test, just random question. Yes, any answers? I think this question will not be so difficult by now. We have done 2 to 3 questions already. First segment, it's a semicircular arc. Right now only we did it. So I'm just writing the net magnetic field directly. Remember, in the exam, write down it separately, B1, B2, B3, B4, then take the total B net. Don't do it in one step, otherwise you can lose your marks. I am doing it in one step because you people must have tried it at least once. See, semicircular arc, mu naught I alpha divided by 4 pi r. That was just derived. All of you remember in the today's class introduction part only we have done. So for the first one, mu naught, current is I, alpha, what's the angle? Angle is pi by 3 divided by 4 pi r. What's the radius for this? This whole radius is 2r. So pi gets cancelled. How much is this? 4 into 2, this is 8. 8 into 3, 24. So this is mu naught I divided by 24r. Direction will be the same. This is going clockwise, so clockwise inwards minus k cap. Okay, this is not a net magnetic field. This is the first one. Let me write the first one. Otherwise, if I write down it directly, it can be confusing. Fine. Now, magnetic field because of the second one. Can anyone answer even without calculating? Magnetic field for this because of the second segment. Anyone from the class? Yes, sir.
Mu naught I upon 12R.
For this second segment, this one.
No.
For this, you're saying no. I'm asking for this. Yes, class. This segment. Point is lying on its axis. It will be 0. Why did you people even calculate this one? There is no need to calculate or try anything in this. This point is lying on this axis. See, this is the axis. So magnetic field 2, this will be 0. Now, Samya, you answer for the third one. Samya.
Mu naught I upon 12R.
Mu naught I upon 12 pi, yes, because this will be pi by 3 and here we have 4 pi r only. So pi gets cancelled and how much is that? 12. Yes, mu naught I divided by 12r. Samya, tell the direction as well. That will complete your answer.
K cap.
K cap. Clockwise, anti-clockwise it's going, so outwards K cap. Perfect. And Fahad has already answered for the fourth one. That will be 0. Now the net magnetic field, you can write it down. Net magnetic field will be this one. I'm writing here. Let's let me insert some space. Net magnetic field will be mu naught I divided by 24r minus k cap plus mu naught I divided by 12r k. I noted down, then one derivation is there, which is very important derivation, but the last derivation from this application part we'll do at the axis of circular coil. Note it down, then we'll do it. No, Samya, those dotted lines weren't depicting infinity right now in this case. We have not considered infinite wire. But I had given you this case because here the point was lying on the axis, so you could have considered. Otherwise, this was a finite wire. And right now, finite wire is not in your case, so you will not get questions. You will get questions like this only. If a finite wire is given, magnetic field will be 0, or you will be able to calculate it. Infinite wire will be this, so infinity will be mentioned. Here, these dotted lines are not a part of question. These I have drawn so that you people know you are able to get the radius. If it's infinity, it will have an open end, or it will be mentioned somewhere. Calculate net magnetic field. Fine. In this question, it wasn't. Let's do one derivation. Magnetic field on the axis of a circular coil. Now, circle, let's say such just example, this is a circle. So at the circle, center of the circle, we had calculated the magnetic field, which was mu naught I divided by 2r. If the axis is there, if you take the perpendicular axis of it, this becomes the axis of it, like this. So at this point, you are calculating a magnetic field. At this point, at the tip, this point. So you have a specific derivation for it to calculate it. So this is a circular wire. I've kept it in YZ plane. Fine. R is the radius. X is the separation or length of the axis. A is the point where I'm calculating the magnetic field. Fine. So DL is a segment. I am taking two diametrically opposite ends. For example, if this is a circular coil, imagine it as a circle. I don't have anything circular right now. Circle. So two diametrically opposite ends. Just take two diametrically opposite ends. Because whatever will be the resultant due to these two diametrically opposite ends will be due to all the diametrically opposite ends. See, like this. This is a circle that you have. Now, if you take out two diametrically opposite ends, these two. So whatever will be the resultant answer, net answer that you will get, what will happen? That will be valid for all the diametrically possible ends. And right now, this was a circle. At the center, magnetic field was mu naught I by 4r or 2r. Now the coil has been kept like this. This is the axis of the coil, and at this point, we are calculating the magnetic field. Like this. So we have taken DL from here and DL from here, like this. DL from this point, DL from this point. Because whatever will be the answer will be valid for every DL for the diametrically opposite ends. Fine. So let's see. If this is DL, magnetic field will be in this extended. For this diametrically opposite end, magnetic field will be this dB, and R is the separation. Small r is the new variable that I have taken. My answer should not have small r. That I will eliminate it. How? If you see, this is a right angle triangle making an angle of 90 degrees. So this can be written as under root x square plus r square. I can write my answer and the derivation in terms of small x and capital R. Fine. So this small r will also be equal to under root x square plus r square. So yes, this point is there. This is DL. This is point A. Application before the application of Biot-Savart's law, before applying anything, we cannot solve it directly. These are into two different planes. One is moving slanting, other one is also moving diagonally below. We have to have it resolved. So resolution of vectors, you must have studied resolution of vectors. Let's say this angle is theta. This angle is theta. So if this is 90, this is theta, this will become what? This will become 90 degree minus theta. Fine. This will also become theta. Again, this will become 90 degree minus theta, and this angle will become theta back. Now, if you resolve the vectors, resolution of vectors, which component do we get? Cos component or sine component do we get with the axis here? If I resolve this, can anyone answer this? This is angle. Will it be dB sine theta or dB cos theta?
Sine theta.
Cos theta. See, the axis with which the angle has been made, that is written as cos. So this becomes dB cos theta. And the perpendicular to it, no, this one, this becomes dB sin theta. Similarly, let's resolve this one. This will also be theta. So if you will resolve, this will be dB cos theta, and perpendicular to it will be dB sin theta. Basic resolution of vectors that you have studied in your class 11. Like this, we have resolved it. Now see, because of all the diametrically opposite ends, the magnetic field will be sin theta component along the y-axis will be in different directions, in opposite directions. We did this type of derivation in the first chapter. Yes, we have done this. When we were doing equatorial field, we have done electric field for equatorial point. Yes, Fahad, right. Same concept we have used, yes. So that time a plain triangle was drawn, here a cone is drawn. That's the only difference. Now see, magnetic field dB sin theta are getting cancelled. Agreed? One is upwards, another one is downwards. Both will get cancelled. So similarly, magnetic fields y component for all the DL, for all the diametrically opposite end, will cancel each other. So there will be no net magnetic field towards the y-axis. Are you getting this reason? dB sin theta. See, magnetic field at A due to this, due to DL. We have to apply Biot-Savart's law. Before we apply Biot-Savart's law will be what? Biot-Savart's law will be mu naught I dl sine 90 degrees divided by 4 pi r square. This is there. But before we move on to this, net magnetic field because of y-axis will be what? Along the y-axis, net magnetic field will be dB sin theta minus dB sin theta. Why? Because both are in opposite directions. If you take one as positive, other becomes negative. So this one becomes 0. It means magnetic field, if it is coming for two diametrically opposite ends, if it is coming 0. So for every diametrically opposite end, y component will be 0. So net magnetic field will point in which direction? You will have it along only x-axis. Now, x-axis will be there. For x-axis, dx will be what? It will be dB cos theta plus dB cos theta, right? It will be dB cos theta. So basically you will get what? You will take the integration of dB cos theta. You will take the net magnetic field that is all coming along it. So dB is what? See, dB can be written from here. dB can be written from here. dB is what? Mu naught I dl 4 pi r square. dB you have. Cos theta we have to find out. Cos theta is new. We haven't used cos theta anywhere. So cos theta. If you look at this triangle, this is theta. What will be cos theta? Can anyone answer? See, this is the base, this is hypotenuse, this is perpendicular. What should be cos theta? Capital R by X, X by R, capital R by small r by X. This is the angle. See, this is theta. This is the base of it. This is the hypotenuse. So cos theta is what? Capital R divided by small r. Base divided by hypotenuse. You people have forgotten your trigonometry. So that will be simply capital R divided by small r. So cos theta is what? Capital R divided by small r. So if you put in the value, mu naught I dl divided by what? 4 pi capital R square. This was the magnetic field dl. R divided by small r. Fine. Till here you people agree? No doubt till here? Cos theta divided by r. Integration of it. This will give you the net magnetic field at the axis of it. Mu naught I dl divided by mu naught I dl r divided by 4 pi r square. First tell me, cos theta portion dB, is it clear till here to all of you? Clear. See, regarding the y-axis, what happened? Basically, regarding the y-axis, this happened that one of the dB sine theta is pointing upwards and second dB sine theta is pointing downwards. So if you choose one axis as positive, one direction as positive, other direction becomes what? Other direction becomes negative. So if upwards is positive, downwards will be negative. So if downwards is negative, it becomes what? dB sine theta minus dB sine theta. So dB sine theta minus dB sine theta gives you what? It gives you directly, it will give you 0. Fine. So it will directly give you 0. Now, let's just complete our derivation. So clear now? Is this part clear why it was 0? All. So cos theta also we had calculated. Cos theta came out to be capital R divided by small r. And here we have x-axis, we have the value of dB. We just have to integrate dB cos theta here. If you integrate dB cos theta, see circumference of the circle is, you have a doubt that magnetic field on the axis is 0. Magnetic field on the axis along y-axis is 0, not the x-axis. See in the figure, look at the figure. That's what I was showing to you. All these are pointing in which direction? These are pointing in the same direction. But these are pointing in opposite direction. So magnetic field along the y-axis cancels from every point. But magnetic field from here, this gets added. First tell me, just look at the figure at least. All of you, look at this figure 1 second for 1 minute. I'll complete the derivation in 1 minute. Just see if you have any doubts from the figure, ask me. Then only you'll be able to understand it later. See, it will not become minus on the left side. It won't be on the left side. It is actually, the coil is like this. So if you people are getting confused with this, no, change the angle. Don't consider this angle. Take this angle. This is theta. This is theta. Take this angle as theta. Take this angle as theta. Fine. If it is becoming confusing, then take this angle as theta. Answer will be the same. This component will become cos. This component will become sine. That's the change that will come. See, by just taking theta different, see the answer, what the result you people are getting. This is what? This will become dB cos theta. This will become dB cos theta. This will become dB sin theta. This will become dB sin theta, like this. So sin theta will be what? From here, if you look at this, if this is the angle, if you see the angle, you will get it as sin theta x divided by small r. So see, answer is different over here. Your sin theta will be what? Sin theta will be x divided by small r. Like this you are getting it. Understood? Here this is sin theta, which is x divided by small r. Right? If you change the angle, base by hypotenuse. Yes. No, that was for cos. You're answering, Fahad, for cos, no? You're right. You have written it for the cos theta. Cos theta is capital R by small r. Yeah? All right. If you take sin theta, see, it will get changed. It becomes x by small r. So let's complete this one only. So this will be what? Yes, integration of dl. Integration of dl will give you 2 pi r. So mu naught I divided by 4 pi r square, r by r into 4 pi r. No, not 4 pi r, 2 pi r. Upward portion is becoming confusing. What are you asking? Upward portion means which portion? So do one thing, note down till here. First note down till here. Then any doubts if you people have, then I'll ask you, because this was the part only. At the end, we just have to combine everything. Leave it till here. We'll combine it at the end. Once it gets clear, no, then we'll combine it at the end. So do one thing. If this figure is becoming confusing, till here note it down. Then at the end I'll combine it, because once you've understood till here, then at the end combining it becomes easier. And take the previous angle only that I was explaining. So take the previous angle only. At least copy down it till here. Now again, if you people have any doubt, others also, not to you only. If others are also having any doubts, ask me. Note it till here first. And one more thing. Since the separation in this law, no, in Biot-Savart's law, this time we have taken it as small r. Separation between the dl and the point, we have taken it as small r. So in the formula also, no, we'll put it as small r only. So dB for us, it will be mu naught I dl divided by 4 pi into small r square. We'll put small r square only. So see, this was along the y-axis. Y-axis gets cancelled. We just have to integrate it along x-axis to get dB cos theta. Now see. So just put in the values. Magnetic field, net magnetic field will be what? Integration of it. Put the value of dP for the net magnetic field. It was mu naught I dl divided by 4 pi small r square. Put cos theta as I by small r, and then we have to integrate it. So rest of the things are constant. Mu naught I capital R divided by 4 pi. This becomes r cube integration of dl. So integration of dl will be, yes, correct. It will be 2 pi r. Right. So if you put it as 2 pi r, this becomes mu naught I r divided by 4 pi r cube. Integration of dl gives you 2 pi r. Now this was the formula. This is the answer that you have. 2 becomes here. See the net magnetic field. That's why I was saying, if you have understood till here, that was I was emphasizing to understand till cos theta. Because this is just combining. Net magnetic field will be what? Bx plus by. By is 0. This becomes what? This becomes mu naught I capital R divided by 2 R cube. R we have to eliminate. We had put in a value. So this becomes mu naught I R divided by 2 x square plus r square under root, no, so it becomes 3 by 2 because r was under root x square plus r square. So x square plus r square to the power half we can write it, and because of this cube we get it as 3 by 2. So that's the formula. Just note this page as well and text me done. Now tell me, now is it clear? You just had to combine it at the end. So cos theta separately, dB separately, integrated. And this integration you have already studied how to integrate dl. Just
Ma'am, can
text
you
done.
explain that last part?
Which one? How to write this cube? See, small r is what? Small r is under root x square plus capital R square. Look in the figure that you have drawn, right, Fahad?
Yes, yes.
So under root square is written how? To the power half. So it's like r is to the power half with this cube. That becomes what? Whichever quantity, 3 by 2. And we have just put in the value of x. Yeah.
Yes, ma'am, got it.
And what about others? Completed? All right. So all those who have completed, you can leave the meeting. We'll continue in the next class. Now we'll start with Ampere circuit law. If you have doubts, you can stay. You can ask me. I'm here. And please revise the derivation. Yes, yes. I'll scroll up. So all those who have completed, you people can leave. Till where, from where, Fahad?
Yes, yes, from here. Can you explain that why cos theta is capital R by small r?
Cos theta, yes. See. This is the triangle. I'm drawing the triangle separately. All right, then see. This is the triangle. This is x, this is small r, this is capital R, this is theta. So cos theta, you have only answered it correctly, that it's base, this is the base, this is perpendicular, this is the hypotenuse. I have drawn it straight way now. Now see, cos theta will be what? Base divided by hypotenuse. So this will be capital R divided by small r. Clear?
Yes, ma'am, got it.
Okay, have you copied it, the writing portion?
Yes, ma'am.
Fahad, did your numericals problems and everything that got solved? Were you able to do the questions? Because the last question that you've submitted, that was correct. Everything, calculation and writing, everything was correct. So where in whichever questions you're not...
First two questions I didn't do. Like from that
First-
assignment number 3.
From that assignment you have done first two questions correctly.
No, first two questions I didn't do.
Okay, you're not able to do or you didn't try?
Like I cannot do. I
You
was
were
not
not-
able to do.
You were not able to do. No, you tried it
Yes.
once at least. Okay, just submit. Just click me a pic. Just send a screenshot of this, and because number-wise assignment, no, I don't remember it. So if you submit the pic, no, I'll just send you the solution. Fine.
Okay, ma'am.
And in that question, no, one question I think you submitted. Just a second, where I told you I'll tell you the solution. Just a second, let me see. There was a question you were solving.
Yes, it was the first one. First question.
Yes, from this assignment 3. No, see, this is correct. In the exams, no, most probably you get the values which are often correct. So here you have written till here you were able to do 10 to the power minus 7 into I think 12.5 into 0.03 square. Even if this question also comes in the exam, you will be able to do. See how 0.3 square plus 0.04 to the power 3 by 2. Like this. Now you had to solve it further because especially in the circular arc, no, which we have completed it right now, you will be getting this kind of scenes again. So this you can easily solve. This is 2. This you can put as 3.14. This is already 12.5 and square of 3 is 9. And again, 2 decimal values ahead of it. Till here, the numerator you will be able to do. This denominator also you will be able to write 0.03 into 0.03. This you can solve it in this way, 0.04 half to the power 3. So this becomes what? Under root of 0.04 becomes what? 0.02. Under root 4 is what? 2. Then cube of it. So this can be 8, 0.00 something else, 8, like this. Got it? How to solve it? Then simply add it with this and divide all of them. Clear how to proceed?
Yes, ma'am, got it.
All right, like this only. Just make it into bits and pieces and see. Otherwise, I think your writing portion from the examination point of view is also correct. You are able to write all the steps. So whichever question you are getting stuck, no, send me the screenshot of the question from whichever book, if it is there, from any assignments if it's there. Fine.
Okay, ma'am. Yes, some questions are difficult in the assignment.
Certain questions are difficult.
Yes.
Some are straightforward as well because you have to have one step ahead of the board exam. No, so at least you will be